Hello everyone again. Let's talk about, as you can see up here, Tech Math 1 chapters 3 and 4, let's talk about Tech Math 1 chapters 13 and 14 review. So far we have done reviews on Tech Math 1 chapters 1 and 2, chapters 3 and 4, chapters 5 and 6, chapters 7 and 8, chapters 9 and 10, chapters 11 and 12, and now Tech Math 1, chapters 13 and 14 review. So here we are. In numerous places in this particular review, they're asking you to look at something on the graphing calculator. I'm not going to be doing anything on the graphing calculator right here per se, but in person, in class, we can talk about it if we need to talk about it, whenever we need to talk about it. The big thing in all instances is to work really hard and very fairly, honorably do these problems and do your best to get them right. If you get the right answer, that is the big deal. And if you do it in a manner and you have to do it in a manner that's ethical, get the right answer, that's really the important thing. So there are graphing calculators, I'm sure more than one kind, and there are obviously computers and computer programs that can give us a lot of the answers when we plug in the data that we need. What I'm doing here is I'm going to do everything old school, and then we can always go back and look at graphing calculators, whichever ones we want to look at, and we can look at computerized programs if we need to as well. But right now, let's see, okay, I don't have much of anything here. Let me get the right answer somehow, either by the addition method, the substitution method, sometimes they call the addition method the elimination method, using matrices and determinants. There's a number of ways we can go here with that. So let's kind of play it by ear when we're doing this. The big thing is let's honorably work hard and get the right answers. That's the bottom line is, let's know the mathematical concepts involved to be able to get the right answers. So with that in mind, for problem number 1, they're saying state the number of solutions for a system of equations whose graph is described as ABC. A, two parallel lines. There's no solution. They don't intersect. There's no solution for that. One line, if they lie right on top of one another, there are an infinite number of solutions. Infinite number of solutions. This is two-dimensional space we're talking about. Infinite number of solutions does not mean the entire two-dimensional plane. It means the entire line, which is identical to the other entire line they lie right on top of one another. There's an infinite number of solutions, and they lie on, so it'd be the set of all x such that y equals mx plus b, and they're identical. So whatever lies on the line is what's going to bring it to that. All right, so let me try to get that together a little bit. When two lines intersect like this, there's one solution. So we've got this for the two intersecting lines. Got that for the one line, infinite number of solutions. Looking of that form, more or less. And the two parallel lines, there's no solution. Why? The two parallel lines don't intersect anywhere, so there's no solution. If two lines are parallel, there's no intersection. The intersection implies a solution or solutions. Two parallel lines don't intersect, there's no solution. One line lies on the other line, there's an infinite number of solutions of this form, and two intersecting lines, one solution. There's one place where it intersects. let's just make sure we're speaking the same language there, guys, because language can kind of get a little confusing. So none, infinitely many, and one. Okay, sounds good. For the rest of these, I mean, they want us to kind of look at it. And see what you're going to do. Okay, so let's knock it out according to the way I said we're going to do it last time. If you were going to graph something like this, it's its own interesting dynamic, I guess you could say, regarding this. So let's see here. You could do for this, let's get at least a ballpark idea of where this is going to be. If I take the top equation, add 2y on each side, add 2y on each side, and subtract 5. So let me take this guy, add 2y on each side, and subtract 5. We get here, divide by 2. Well, that's one of them. See if I can give myself a little bit of room here. And the other one is, why don't you subtract 3x on each side? We got this. Let's do a t-chart. Let's get an idea here. Is there an intersection? Are they the same line? Sure don't look like the same line. To have the same line, you have to have the same slope and same y-intercept. If they're parallel lines, you have to have the same slope and different y-intercept. Try to make this thing relatively easy to look at, or hopefully easy to look at. Let's put a 5 in here, I guess you could say. 5 in for x. A 5 in for x. 1/2 of 5 is 2.5. 2.5 minus 2.5 is 0. Let's put a 2 in here. 1 over 2 times 2 is 1. 1 minus 2.5. So 1 minus 2.5 is negative 1.5. I don't know, there's a lot of things you could say here, I guess. Put a 0 in here. 0 times 1/2 is 0, minus 2.5 is negative 2.5. So looking at this, let me graph this one. Positive slope, slopes upward to the right. Negative 2.5, negative 1, negative 2, negative 3. Here's negative 2.5, 0. I took the very last one, that one right there. 2 and negative, let's see here, right. 2 and 1, and negative 1.5. So 1, 2, negative 1.5. 5 comma 0, 1, 2, 3, 4, 5. Again, this drawing's far from being that great, but it's looking something like that for that one. For this one, put a 0 in here and get 1. Put a 1 in here and get negative 2. Something like that, and put a 2 in here and get negative 5. So here we got, for this one right here, as it's going, we got this, 0, 1, 1 comma negative 2. Here we go. Right, go a little lower maybe. I don't know, 1 comma negative 2 right here. 2 comma negative 5. 1, 2, 3, 4, 5. Okay, so 2 comma negative 1, 2, 3, 4, 5, negative 5, 2 comma negative 5. we're right about here. So somewhere in this vicinity, it looks like something like 1 comma negative 2. In fact, it is. I mean, if you put a 1 right here, for x. If x is equal to 1, let me put it over here. Let me kind of extend this, I guess. Put a 1 right here. 1 times a half minus 2.5 is negative 2. That's 1 comma negative 2. That's 1 comma negative 2 over there also. There's your answer. The answer is x equals 1, y equals negative 2. That's this answer right here. X comma y equals 1 comma negative 2. That's hard to do by hand. That's why we have graphing calculators, and that's why we have computer programs and things of the like. But hey, we got into the ballpark of where we need to go. There's a number of, so that's it. It's as simple as that. You could have said, you know, there's the answer. Now, I can do this in different ways and still get the right answer. It better be the same right answer because there's only one right answer. So let's kind of, there it is. X equals 1. Let's see what we got here. X equals 1, y equals negative 2. You could have, again, at the end of the day, guys, we have to know the mathematics. The more mathematics that we know, the more things that we can do. Let's get this thing done. Let's get it right. Let's use the elimination method, addition method. Let me double the bottom equation here and get 6x plus 2y equals 2. Let me leave that guy as is. It's just an x. It's just a minus 2y. And it's just a 5. The x is the same as 1x. Add the two equations. These go. Add these two. You get 7x equals 7. Divide by 7 on each side. X equals 1. That's already looking familiar. If x equals 1, plug it into 3x plus y equals 1. Subtract 3 on each side. X equals 1, y equals negative 2. That's awfully familiar. Yeah, it better be the right answer, right? We've done it before. See what we got here. For number 3, they're saying use the substitution method. Wherever you see a y up here, we know from the bottom one that y has to equal this for there to be a solution. So wherever I see a y up here, in place of y, I'll say that y equals this, 5x plus 1. So here we go. Take 4x plus 3y. We said y was 5x plus 1. And it's equal to this, the 22. Let's go for it. Let's see. And then after I get the x, I can plug in here and get the answer. 4x is 4x. 3 times 5x is 15x. 3 times 1 is 3. Just distribute. Take this and this and add them together. Get 19x plus 3 equals 22. Subtract 3 on each side. You know where we're going on this one. Subtract 3 on each side. We got this. Divide by 19 on each side. X equals 1. X equals 1. 1 times 5 is 5, plus 1 is 6. There you go. X equals 1, y equals 6. And there we go. Keep going. They're saying here, use the addition method. At the end of the day, guys, when you're confronted with a problem, as an electrician, as an electrical engineer, as a mechanical engineer, as any kind of engineer, as a physicist, as a mathematician, as anybody using mathematics in any way, at the end of the day, you have to get the right answer. You approach that the way you feel is most appropriate, but you got to get the right answer. Addition method, we got this right here. It really lends itself to it. I'll tell you what, just add them as is. 2y and negative 2y is out of there. 5x and 3x is 8x. This and this is 32. Divide by 8 on each side. We've been doing that enough. Just dividing on each side. X equals 4. Looking pretty good. If x equals 4, let's go to one of these two. Go to one of the two originals and look at it. Say, well, x equals 4, huh? X equals 4. Let's just grind this out and solve it. You go here, you got 20. Here you got 2y. Here you got 4. Subtract 20 on each side. Divide by 2 on each side. X is 4, y is negative 8. We'll go back and double check these guys. Sometimes things can go a little haywire. And there's your answer for that one as well. For number 5, find the addition method. It's a little more complicated in this instance. I may need to erase a few things, but let's just, before we do so, let's just make sure everything's on the mark here. We should be okay. Number 1 we were fine with. Number 2 we were okay with as well. 3, the 1 comma 6 we got, sure. 4, the 4 comma negative 8, looking pretty good. So we got that. Let's talk about 5. Now this was getting a little bit rougher, but again, you can add the opposites, you can do whatever you want. At the end of the day, folks, you need to be able to do this. Well, that's it. You need to be able to do this. Make sure we know what we're doing, know as much as we can know as much as we can know, and let's do this right, and let's get this right. A lot of looks you could take at this thing, I guess. Here's a negative x, here's a positive 2x. I'd probably double the top one and get negative 2x. I'm just doubling the top one all the way across. You get negative 2x, positive 8y, 14 right here. Leave this one alone. The minus 3y is plus a negative 3y. I don't know if you need to do anything about that. We do know the drill on that if we need to do it. Negative 2x and positive 2x is nothing. Add 8 and negative 3, you get 5. 8y and negative 3y is 5y. This and this is 5. Divide by 5 on each side, right? You get to here. A lot of times I'm just saying it and not doing it. Here I'll explicitly write it down. But you know what to do at that point. You divide by 5 on each side. Y equals 1. Y equals 1. Only thing I need to do now, if y equals 1, I just need to find what x is, and we should be in pretty good shape. Okay, so y equals 1, looking good. I always forget that we're on film, so you can always go back. So we said y was equal to 1. If y equals 1, go into either one of the two original equations and get it done. Well, there's no subtraction going on here. Here there is, you can argue this a whole bunch of ways, I guess. Let's go to the second one. Let's take 2x minus 3y equals negative 9. 2x minus 3y equals negative 9. Let's go. 2x, I don't know what x is. I don't know what 2x is. Minus 3y, y is 1, we said. 2x is 2x. 3 times 1 is 3. Minus 3. Sounds good. Let me add a positive 3 on each side. Negative 3 and positive 3, out of there. You've got 2x. Negative 9 and 3 is negative 6. 2x equals negative 6. Divide by 2 on each side. Negative 3. X equals 1. X equals negative 3. Didn't have a whole lot of room on that one, guys, but there it is. So when you're looking at it, x equals 1, y equals negative 3. Make sure that's right. Forgive me, that is wrong. What I wrote down initially is what's right. I just don't know how to copy things. It's been kind of a long day already. X equals negative 3, y equals 1. There you go. So let's make sure. Right. X equals negative 3, y equals 1. Yeah, absolutely. That's it. Okay, guys, looking pretty good. Let's go to 6 onward. They're asking for, graphing. After number 6, we're going to use the addition method. It's 3 equations and 3 unknowns. Pretty interesting stuff. And then they go, your problem 7, 8, 9, and 10. They say, okay, how could you graph these with your graphing calculator and things of that nature? How are you going to get it? Make a rough sketch, do the whole thing. I'll tell you what, let me just solve those. And we assume that if we were to graph them like we've already been graphing, I think I may have, I ended up erasing here, but as you saw we actually did do a graph. And again, you can do it with the graphing calculator as well. I am just going to run through them and solve 7, 9, and 10, just kind of old school. We'll see what the easiest way is to do that, and we'll kind of take it from there. But for 7, 8, 9, and 10. But let's do 6 first. Let me set this thing up a little bit, guys, and we'll take it from there. Let me just put this on pause for a second, and we'll come right back to it. Okay, everyone, let's keep going. Let's go to number 6. 3 equations and 3 unknowns. You got to find x, you got to find y, you got to find z. X, y, z is what we have to find. 3 equations and 3 unknowns. This is really, these 3 linear equations and 3 unknowns is indicative of 3-dimensional space being looked at, and there's theoretically 3, in this case, they're all different equations, so there's 3 planes in 3-dimensional space all present, and they all intersect at one point. That one point is going to be x comma y comma z. We can do this in the method I'm about to show you, kind of the elimination method, addition method. There's also a determinant method as well. Like I said, we're staying basically by hand doing these things, at least know how we're doing this. And let's get this thing right. Now look, there's a lot of ways you can look at this. you can leave this kind of as is. What I do is x means 1x. Negative x means negative 1x. Y means 1y. Minus 3y is plus a negative 3y. Minus z is minus 1z, that's plus a negative 1z. Here I'm pretty explicit about making addition happen everywhere. You take a look at these three equations in three unknowns, and you pick one of them to be like a battering ram to hit the other two. You can pick, there's a lot of ways to start, there's about 9 different ways to start this problem. So, you know, you could pick any one of the three equations to hit the other two equations, and then you can start it by getting rid of a particular variable, whatever variable you want to start getting rid of, and there's any one of 3 variables you do to get rid of. Basically, you're going to make this into a situation where you're slowly knocking this thing down from 3 equations in 3 unknowns to 2 equations in 2 unknowns, solving for x and y, or solving for x and z, or solving for y and z. For any 2 of them you solve it, then you plug it in to one of the 3 initial ones, and you find the 3rd variable. And x, y, and z are therefore solved. So it's usually easier done than said, so let's do it. These ones look pretty easy to look at. I'm going to use this as the battering ram equation to hit each of the top 2 equations. So what I'm going to do is, I'm going to say, okay, then I got to decide what I'm going to get rid of. Well, there's a lot here. I mean, there's a lot here, there's a lot you can get rid of, a lot you cannot get rid of. As I said, I could have started this any one of 3 different ways. And then after that, gone another 3 ways for each one of those 3 different ways. 3 ways to start it, another 3 ways for each one of the starts that I do. 3 times 3 is about 9 different ways you can start this initially. I don't know what the best thing to do is. I'm thinking this. Why don't you take this equation and add it on to 2x, but I want to get rid of the 2x, so I'm going to have to double this equation. If I double this guy, leave it alone right now, but in your mind or somewhere, write it down, take this guy and double it. Got to be careful here. Just double it all the way across. Negative 2x, positive 2y, positive 4z. Here's a 4. And I'll add it onto this guy right here. Here's your 2x. Here's your negative 3y. Here's your 4z. Right, 2x plus negative 3y plus 4z equals 3. Add them. You engineered it so that they fall out. So what do you have then? You got 2y and negative 3y is negative 1y. You got 4z and 4z is 8z. You got 4 and 3 is 7. Okay, let's go back to what we just did. We took the battering ram equation. And doubled each side of the battering ram equation, which got us this. Then we took this and added it onto this guy over here, which is what I did right here, giving us this. What have I accomplished here? Well, I've gotten rid of the x variable. I got y and z. I am now going to solve for y and z and then work my way back to solve for x. But to do that, I got 2 unknowns right here. I need another 2 unknowns with the same variables. I got y and z is unknown. I'm going to get another equation with y and z unknown, and it becomes 2 equations and 2 unknowns. We just played the game here, and that was fine. Now let's take this guy, leave him alone, because I'm going to get rid of the x again. You got to get rid of the same variable, or else you're going to spin your wheels a bit. Leave this as is, and add it onto the top one. Didn't really have to do much manipulation there. That's why I took this one from the get-go. There was just ones in there, just easier to manipulate them if I needed to do so. So what do we have? Negative 1x and positive 1x is 0. I wanted that to happen. Add these, you get 5y. Add these, you get 1z. Add these, you got 6. 5y plus 1z equals 6. 5y plus 1z equals 6. Okay. I've accomplished something there. I've taken 3 equations and 3 unknowns. I've manipulated them in such a way that I now have 2 equations and 2 unknowns. It's still important. They're still here. They're still here. And you're still going to work with them. Definitely still going to work with them. You know, 3 equations, 3 unknowns, but we did some manipulations. We got 2 equations and 2 unknowns. Let's solve. I mean, again, guys, the goal is to solve for x, y, and z. Let's see what happens here when we do this. I'm looking at this. I suppose there's a number of ways we can do it. What do you want to get rid of? I tell you, well, let's get rid of the y in this case, and let's end up solving for z and then work our way back, I guess you could say. Tell you what, let me take the top equation, and let me multiply by 5 all the way across, and end up getting this. Let me leave this guy alone, because it's already a 5y there. Looking good to me. You engineered it so they come out to 0. You make it. You multiply. Combination of some stuff to do sometimes to get the right answer, but you got to do it. You got to like get rid of something. Let's get rid of the 5y. Let's multiply by 5 all the way across, and you got this. Add them together. Negative 5y and 5y is nothing. This and this is 41. Divide by 41 on each side. Z equals 1. Not bad. I don't know how far over I'm going. I probably don't need to go too far over, apparently. But let me just do it anyway. So basically, guys, I'm trying to find x equals something, y equals something, z equals something, which is going to be x comma y comma z, and it's going to equal whatever I'm going to get there. There's some commas there. Let's see what we can do. Well, z equals 1. Good enough for me. If z is equal to 1, let's go back to one of these two. Let's start working our way back that way a little bit. But if z equals 1, let's go into here. Let's take the 5y plus 1z equals 6. 5y plus 1z equals 6. Z equals 1. 1 times 1 is 1. 5y plus 1 is equal to 6. Subtract 1 on each side. Divide by 5 on each side. Kind of a boring answer on the whole thing, but it's happening. Y equals 1. Okay, that's kind of interesting. Y equals 1. If y equals 1 and z equals 1, why don't you find your way into one of these 3 equations? Any one of these 3 equations will make it work. This was probably the easiest one to look at. Let's look at it. Let's see what's going on. The negative 1x, let's look at the last one. The negative 1x plus 1y plus 2z equals 2. Negative 1x plus 1y. Let's see what we got here. The negative 1x plus 1y plus 2z equals 2. Don't know what x is. So I don't know what x is. It's simple as that. Y is equal to 1. Z is equal to 1. I've got negative 1x here. 1 times 1 is 1. 2 times 1 is 2. Got 2 right here. Negative 1x. 1 and 2 is 3. Subtract 3 on each side. Divide by -1 on each side. This is about as boring as it gets, guys, but it's what it is. It's what it is. X equals 1, y equals 1, z equals 1. Yeah, that's what it is. X equals 1, y equals 1, z equals 1. 1, 1, 1. It's an ordered triple. You know, there's more, you know, a little more challenging look to some of these problems, but it's not an unchallenging look. You got to just do the process that you got to do, and it turns out really nicely. It's the right answer. That's the end of the day. What you're looking at. Yeah, for number 6. Absolutely. Absolutely. For number 6, x equals 1, y equals 1, z equals 1. Yeah, absolutely. That's the way it is. So we can see a lot of stuff here, guys. We can go back now. We can go to 7 and 8 right now and look at some things that are of importance, I guess you could say. You can write these in slope-intercept form, do a graph of one of the equations, graph of the other equation. Where they intersect, if they do intersect, is where your solution is. If they don't intersect, there's no solution. If they lie right on top of each other, there's an infinite number of solutions, like we talked about earlier. And if they intersect at one point, that is the solution. So there's ways you can do that, either like graphing, and of course, more accurately with a graphing calculator or a computer program. For our purposes right now, let's just knock through this thing and just get this right. Know how to do this. If this gets thrown at me, some kind of equation like this, how am I going to handle it? You know, because there are classes. I mean, the classes I've actually taught in other places where you're not using a graphing calculator. You just got to know how to do this stuff. I mean, I don't know, maybe for the homework they'll let you use it, certainly, but for an exam, in-person exam, it's not allowed in a number of classes. Sometimes that depends where you go. Of course. Let's take the top guy and double it all the way across. You'll see why I'm doing that. Now add it to the bottom guy. The 2y and -2y out of there. This is 13x. This and this is 26. 13 times what number gives you 26? You know it's 2. Divide by 13 on each side. X equals 2. Just have a look at it, guys. I'll leave it up there. I'm, of course, going to erase it. Again, I'm always forgetting that this is a film, so you can always go back. So x equals 2. If x equals 2, you can come back to the original two equations and pick one of the original two equations and put x equals 2 in there and solve for y. Shouldn't be too bad. All right, so what we're looking at is x equals 2, huh? All right. X equals 2. I'll put it in the first equation here. 5x plus y equals 11. X equals 2. 5 times 2 is 10. Subtract 10 on each side. You're done. There it is. That was the manipulation that took place. Okay? What we have here is x comma y Okay. Same kind of argument coming on over here. I think the easiest way to go is get rid of the 8y by adding a negative 8y. How do you get a negative 8y out of here? Multiply the 2 by 4. Multiply the negative 2 by 4 and you should be okay. Multiply the top by 4 all the way across and you get, you take this top one, you multiply all the way across on each side of the equation. That's what we've been doing everywhere here. Multiplying across on each side of the equation. Multiply by 4 on each side of the equation. And you got this, multiply by 4 on each side of the equation. You got this, that's 8y, if you multiply by 4. Okay, so take the top, multiply by 4 all the way across, and you get this. Then we got this. Sounds good to me. Let's add them. Negative 8y and positive 8y is nothing. You engineered it to be nothing. You add these two, you got this. You add these two, you got 11. 22x equals 11. Divide by 22 on each side. X equals a half. Okay, you know, a little different look to it. So if x equals a half, just pick either one of these top two equations, pick either one of them, and plug in x equals a half, and then solve for y. I'm thinking the second one looks easier. Usually I go for places where I don't see too many negative signs. Hopefully no negative signs. Not a problem if I do, but you know, maybe it's a little easier if I don't. So x equals a half. Here we go. X equals a half. Let me go here. Two x plus 8y equals negative 5. X is a half. Here's your 8y. Here's negative 5. See how this plays out. 2 times a half is 1. 1 plus 8y equals negative 5. Subtract 1 on each side, or add a negative 1 on each side. Negative 5 and negative 1 is negative 6. Up here. 8y equals negative 6. Divide by 8 on each side. Y equals negative 6 over 8, which is negative 3 over 4. X equals a half, y equals negative 3/4. And that's what we're talking about. Or x equals 0.5 and y equals negative 0.75. X equals 0.5 and y equals negative 0.75. Either way. We said 7 was 2 comma 1, 0.5 comma negative 0.5 comma negative 0.75 for the one that we just did. A lot of ways to write that, you know. Obviously on a graphing calculator they're going to be giving you the decimals on this, so you got to kind of watch out for that as well when we're doing that. But again, these are the basic arguments you're making here, guys. X is a half. Y is negative 3/4. X comma y is a half. Okay, a number of ways to write this, guys. 0.5. certainly means this, certainly means that. Okay, guys. Kind of proceed. Let's take a look at a few of these. Let me try to look at 9, 10, and 11, and a number of ways we can look at them. So let's see what we can do. All right, let me, again, for efficiency, let me pause it and then go back to it. Okay, sorry guys, I turned on some kind of lighting arrangement here, some kind of display here. I don't think anything was getting displayed, but the light was coming on. Accidentally bumped into something here. Let's have a look. Yeah, it should be off now. Okay, let's proceed. We have guys. Okay, guys, let's keep going. Let's see what we got here. Let's look at 9 and 10, solve them the way we've been solving it, kind of, a little bit old school, in fact. And then when we finish 9 and 10, we'll do problems 11 and 12. 11, 2 equations and 2 unknowns, and 12, 3 equations and 3 unknowns. 11 and 12, we're going to solve using matrices determinants. Okay, I'm going to show you here just on the board how you can actually look at it, talk about it a bit. Pretty fascinating stuff. The way you solve linear equations with determinants, and perhaps I think other equations as well, can be looked at with the very useful mathematical object known as the determinant. Determinants are pretty fascinating, and there are proofs as to why you can solve things using determinants. What is the answer of any number of equations? If there's a million equations and a million unknowns, theoretically you can solve those with determinants, theoretically. If that doesn't lend itself to a computer program, I don't know what would. But any number of equations in the same number of unknowns, no matter how many equations and no matter how many those unknowns are, there's always this. You always need as many equations, independent equations. You need as many independent equations as you have unknowns. No matter how many independent equations you have, if you have that many unknowns, no matter how many equations there are, based on what I just said, no matter how many equations you have, if there's this, and they're independent equations, no matter how many of them there are, if you have that many unknowns, you can solve them using determinants. And there's a fascinating proof regarding why that's true. And there's numerous ways you can, there's intuitive ways you can look at it, and there's pretty fascinating proofs, at least one fascinating proof, I'm sure more, and there's just a number of ways you can look at why determinants can be used to solve any number of equations in the same number of unknowns, provided that those equations are independent equations and you have that many unknowns. Doesn't matter. You can have 100 unknowns with 100 independent equations. You can have 100 independent equations in 100 unknowns, 1 million independent equations in 1 million unknowns, 1 billion independent equations and 1 billion unknowns. Theoretically, you can solve them with determinants. Well, we're not going to go, we don't need to go to that level, but we could, theoretically. But 11 and 12 will involve solving things using determinants. 9 and 10, let's just keep doing the way we've been doing it. Let's take this guy, the top one, multiply by 3 all the way across. And you end up getting 18a. Add that to the second equation. You engineered it so they cancel. I wanted 3b and negative 3b to cancel, and they did. Add these two. Add these two. And you've got 11. Divide by 22 on each side. (11 over 22) is a half. You put a equals a half into either one of the originals and you're fine. I tell you what, the top one looks pretty good to me. 6a plus b. A is a half. A is a half. A half of 6 is 3. Subtract 3 on each side, or add a negative 3. You got to be careful. You don't want to get a negative 1 here or something. We really want to be careful what we're doing here, guys. B is equal to negative 5. So we got B is equal to negative 5. We got A is equal to a half. A equals a half. B equals negative 5. Sounds good. Sounds good. That's the answer. A is a half, B equals negative 5. Yeah, A is a half, B equals negative 5. A is 0.5, B is negative 5, or A is a half, B is negative 5. That's not an issue. Same kind of arguments going on right here, you guys. I'll tell you what, let's get rid of the y's. It just seems like the easiest way to go. Here's a 2y, here's a negative y. Multiply the top by 2 all the way across. 2 times 3x. 2 times negative y is negative 2y. 2 times negative 8 is negative 16. Take this one. (6x) and 5x is 11x. This and this is nothing. This and this, when added together, is negative 24. I just want to make sure this is right. It just seems for some reason, yeah, it looks pretty good to me, actually, guys, to be honest with you. Negative 24, you got this. The other one, you multiplied. Yeah, you multiplied by 2 all the way across. You got what you got. Yeah, there's not a real pretty answer at the end of the day here, but we got what we got. X is negative 24 over 11. That's what it is, guys. If X is 24 over 11, I mean, it's going to be a little bit of a mess. Let's solve for Y. Y is going to be solved. We're going to use the second equation right here. 5x plus 2y equals negative 8. 5x plus 2y. 5x plus 2y equals negative 8. X is negative 24 over 11. 2 is 2. Y is y. 5 times negative 24 is negative 120 over 11 plus 2y equals negative 8. Yeah, I suppose there's a number of ways we can go here. Give myself a little bit of room here, then I'll just get rid of it after the fact. What do you say you add a positive 120 over 11 on each side? Okay. Well, let's see what we can say. There's a number of ways to go. I could argue this a bunch of ways, I guess. Is negative 8 the same as negative 8 over 1? Sure is. Is 11 over 11 the same as 1? Negative 8 over 1 times 11 over 11 is negative 88 over 11. So this right here, the negative 8 becomes negative 88 over 11. 2y is 2y. Add these two, and you get 32 over 11. Yeah, sure sounds about right, doesn't it? 32 over 11, divide by 2 on each side, or multiply by a half on each side. Divide by 2 on So you can multiply by a half on each side, or divide by 2 on each side. Multiply by a half on each side. You get y equals a half right here. The 2 goes into 32 16 times, 16 over 11. So that's pretty neat. Y equals 16 over 11. Sorry about that, guys. So there they are. Dividing by 11 is, you're inviting a lot of stuff here. It's saying, basically, when you do this, make sure your answer, is rounded to the nearest, I think, 100 in this case. So let's see what that was. That was number 10, rather. I'm sorry. Rounded to the nearest 100. They got x equals negative 2.18 and y equals positive 1.45. Let's see if that's actually where we're going. There's the answer I got. That's the exact answer, actually, that you're getting here. So we saw how we worked it, guys. We saw how we got the answers. Well, there's the answers I'm claiming we have here. Do they round to the way they're asking you to get the answers here? Negative 24 negative 24 over 11 2.18181818. Well, 2.1818 just rounds off to 2.18. And a negative, of course. (16 over 11) 1.454545. Not by much, but it stays rounded like that. And that's the stuff that they were talking about. Negative 24 over 11 rounds to negative 2.18 to the nearest hundredth. 16 over 11 rounds to 1.45 to the nearest hundredth. Okay. Right, negative 2.18, comma, 1.45. Sounds good. Let's look at 11, 12, and 13. Did I actually put 13? No, that's 12. Let's see here. Rather, that was 10. Sorry, guys. Following these is not easy sometimes. 11, 12, 13. Let me see where I actually did that. Just go 11 and 12 for now, and then we'll bump that up a little bit more to 13 and 14 later on. Let's keep going with this. Let's see what we can do. They want determinants with this. Now, I've already kind of delivered the speech on determinants, how important they are and useful they are. You have got to get them to be in the form of constant far over to the right and all the letters in order with one. Action present, you have to convert it to addition in plain English. 5x on each side. That's the right form. Add a negative 4y on each side. Add a positive 14 on each side. Okay. This is where you start. This is where you start. You have a column of x's, a column of y's, and a column of constant terms. You have to have the x's all in line with each other in a column, the y's all in line with each other in a column, and the constants all in line with each other to the far right. Whenever there's any subtraction, you have to convert it to addition. The coefficients always have to be associated with addition having taken place. Now, there's a lot that goes on. Let's, I'll probably got to erase a little bit and go for it. Right here, if you want to solve for x is going to be a determinant associated with the x variable over the major determinant, d. Y is going to be a different determinant, d sub y, associated with the y value, but the d on the bottom is the same as that d. Now we got to find out who's who and just do it. What's dx, what's dy, and what's d? It's the same in each instance here. So with that in mind, all right, guys. Well, I mean, that's a good question. Let's answer it. The determinant, and the way you're going to see me do this in class whenever we need to do it in class, I'm not going to, I won't do the lecture start to finish on this, but there's shortcuts for doing a 2 by 2 determinant, and there's shortcuts for doing a 3 by 3 determinant, and we're just going to use them and be able to do our job, be able to do what we need to do. The D that we're talking about, the major determinant, is you're going to take the coefficients in the x column, 5 and 2, and the coefficients in the y column, 3 and negative 4. And that's D. That's what the D is. How do you do it? You multiply here, and you call it plus. You multiply here and you subtract it from what you got here. 5 times negative 4 is negative 20. 2 times 3 is 6. You're minusing the 6. Negative 20 minus 6 is negative 26. Well, there's your D. Negative 26. Then you take the dx. Now the dx, you just simply substitute columns. The d sub x, it's going to be wherever there's an x value, and let me just try to think here. Absolutely right. Let me just think this out for a second, guys. I just want to make sure everything is straight on this. Right. Wherever you want to solve for the x, the 5 and the 2 here, you're going to put the constant column, the 9 and the 14, in place of x. Three, negative 4. Let's go. That's negative 36. 14 times 3 is 42. That's minus 42. Remember, it's minus the one going up. This is going to be a minus. This is going to be plus. It's going to be plus. This is going to be a minus. That's what we got here. Minus 42 is plus a negative 42. Add them together, you get negative 78. Fascinating. Let's get the dy. dy is a similar argument. Dy, wherever you see the y column, you're going to put in the 9 and the 14. So it's 5, 2, 9, 14. And play the game. Five times 14 is 70. 2 times 9 is 18. 52. Well, I mean, that's an interesting conclusion. 26 goes into negative 78. Forgive me. Negative 26. Negative 26 goes into negative 78 3 times. Negative 26 goes into 52 negative 2 times. I think we just found the answers. That's the way it's working. We get everything out of there. You see this. Again, you've got it on the film here. Let's actually have these things tell us what the answer is, and we'll take it from there. What is going on? Well, yeah, it's basically this. X is d sub x divided by d. D sub x divided by d. Y is d sub y divided by d. x equals y. X equals 3, y equals negative 2. Yeah, x equals 3, y equals negative 2. That's 3 comma negative 2. Okay. I mean, so it's looking pretty good there, guys. Let's look at number 12. Number 12 proceeds essentially in the same manner that I just showed you how to do problem number 11. Problem number 12 will proceed in essentially the same way as I taught you how to do problem number 11. Yeah, it's a little more complicated. It's 3 equations and 3 unknowns. But it's a very similar argument, so to speak. It's the way it plays is, let's kind of look at it. There's a d sub x again, there's a d sub y again, but now you got to have a d sub z. And then you got to have a big D right here. And the way it's going to play is x is going to be same kind of argument, d sub x over d. Y is going to be d sub y over d. And z is going to be d sub z over d. All of that plays like that. True. The end, it'll give us the answer that we want. Now, how do we do it? Well, okay, let's give ourselves a little bit of room. Let's get rid of what we don't need, and let's just take a look at 12. Tell you what, you got to put everybody in line. The x is in one column, the y is in another column, the z is in another column. If there's no number in front of a letter and no sign in front of the letter, you just put a 1 in front of the letter. We got that. If there's a subtraction, make it plus the opposite. There's a y by itself, put a 1 right here. Minus y is plus the opposite of y. Minus 2z plus negative 1z. So again, guys, we've got a 1x here, a 1x here, a 2x here, a 1y here, a negative, I don't know how clear that would be. I mean, negative 2z forgive the overkill, guys. Hopefully it's visible. The future, maybe I won't go that hard with this stuff, but there's a 1 right here, a 1 right here, a 2 right here, a 1, a negative 2, a negative 1, a 1, a negative 1, negative 2. Okay, so basically the way it's looking, I don't know if I even improve that, guys. That looks, it's almost, well, if you need to laugh a little bit, laugh at what I just did. I don't know, maybe that's even less clear than what it looked like. The big thing is, guys, make sure that all the x's are in one column, all the y's are in one column, and all the z's are in one column. And if there's any sort of subtraction going on, convert it into addition. All subtraction gets converted into addition. So what you got is, the way that's going to look, let me try to write this maybe a little bit better, guys, honestly. Let's see here. 3 ones across, 1, negative, 2, negative 1. All right, so let me just try to write this again. Maybe it was fine the way it was, but all right, let's maybe make it a little bit bigger, just make it really obvious as to what's going on. That's essentially the argument, you guys. You're looking at 1x plus 1y one z one x plus negative 2y plus negative 1z equals 1. 2x plus negative 1y plus negative 2z. So there you go. Columns. You know, that's the big thing. Look at the columns. Everything we've said, that's the way it's got to play. Now how do we do it? There's a shortcut for 3 by 3. The determinant D, which is going to be on the bottom of all those over there to your far left, the determinant D is just going to be 1, 1, 2. 1, 1, 2, 1, negative 2, negative 1. 1, 1, 2, 1, 1, 2, 1, negative 2, negative 1, 1, negative 1, negative 2. Looking like that. What the trick is, here's one of the tricks. There's other ways to evaluate what's going on here, guys. But there's a shortcut. There's a shortcut for the 2 by 2, and there's a shortcut for the 3 by 3. What we have here is, take these two columns, pick them up, and move them over here while leaving them here at the same time. So you got here, you got a 1, you got a 1, you got a 2, you got a 1, negative 2, negative 1. And then you just go and go here, here, here. You're adding all of these. Then you go the other way and go here, here, here. You're going to add those together, but in the end, you're going to subtract. Here, you're going to add them together, and in the end, you're going to add. This is easier done than said, so let's actually do that. Okay, it's a lot, so just be careful. You're just going to multiply all of them. You're going to multiply all of them diagonally. Multiply diagonally, multiply diagonally. Multiply diagonally, get an answer. Do the same here. Multiply diagonally, multiply diagonally. You're going to take every one of those answers and add them together. So let's see what happens. 1 times negative 2 is negative 2 times negative 2 is 4. Plus, you're adding all these. 1 times negative 2, forgive me. 1 times negative 1 is negative 1 times 2 is negative 2. 1 times 1 times negative 1 is negative 1. You're going to add those together. Then you're going to subtract the guys going upward. You're going to add them together on the inside and then subtract the final result. This is easier done than said. 2 times negative 2 is negative 4 times 1 is still negative 4. Keep adding them and in the end just subtract. Negative 1 times negative 1 is 1 times 1 is 1. Negative 2 times 1 is negative 2. All right, what the heck's going on? That's what D is going to be. So let's take a look at it. This, and this is 1. Minus. Add these together, you get 1. This, and this is negative 5. 1 minus a negative 5 is 6. That's what the D is. Looks pretty good to me. This is negative 6 and 1 is negative 5. Yeah, absolutely. I'll go right there. Then you say, okay, now what are you going to do? Well, you're going to do the same thing about 3 different times. In fact, exactly 3 different times. I'm going to see where this thing goes. Can get a bit tedious. Be the first one to tell you that. Let's try to solve for x. That'll be the d sub x. Get rid of the 1. Get rid of the 1, 1, and 2, and put 4, 1, negative 1. 4, 1, negative 1. So what you got here is you're going to put 4, 1, negative 1 in place of where this was. Everybody else stays the same. 1, negative 2, negative 1. 1, negative 1, negative 2. Pick these up, put them right here, and do the same trick you did earlier. So let's see where this is going to go, guys. You go here. You go, forgive me, you don't go there. 4, 1, negative 1. Let's try that again. Go here, go here, go here. So what do we got? We got 4 times negative 2 times negative 2 is 16. We got 1 times negative 1 times negative 1 is 1. We got 1 times 1 times negative 1 is negative 1. Let's go here. Negative 1 times negative 2 times 1 is 2. Negative 1 times negative 1 times 4 is 4. And negative 2 times 1 is negative 2. Right here we got 18. Here we got 4. See where this is going to go, guys. I'm claiming 14 right here. Just make sure it's right. Just see, guys, for 1 second here. I'm getting answers here I don't like. some reason, I've got something I'm not agreeing with. Yeah, right. That is right. 16 and 1 and negative 1. 16 plus 1 plus negative 1 is 16. 16 minus 4 is 12. And that's dx. That's the dx. And that's basically the argument, guys, throughout the process when you're doing this thing. We are looking at it right. Same kind of argument. I mean, let's just kind of go down the line, knock out the other ones, and at least we have an idea where this is going. It is a bit tedious. It's easy to make a mistake. Well, it's easy to make a mistake at any point, actually, when you're doing mathematics, I think. But let's see if we can knock this out relatively quickly and see if it's making any more sense for us. Well, lose the middle thing for the y and put 4, 1, negative 1. Put 4, 1, negative 1 in that whole thing here. So that's fine. 4, 1, negative 1. Right. 4, 1, negative 1. 1, negative 1, negative 2. And then pick these two up. Put them right here for the trick that they got. It's an interesting little trick. Go here. Get negative 2. Go here. Get negative 8. Go here, get negative 1. Go here, get 2. Go here, get 1. Go here, get negative 8. You add all these together, you got negative 11. You add all these together, you got negative 5 on the inside, right? Got negative 5. Minus a negative 5 is plus 5. 5 and minus a negative 5 is plus 5. 5 plus negative 11 is negative 6. All right, it seems like some good divisions are going to go on. 1, 1, 2, 1, negative 2, negative 1. 1, negative 2, negative 1. 4, 1, negative 1. 1, negative 2, negative 1. 1 times negative 2 times negative 1 is 2. 1 times 1 times 2. So 1 negative 2 times 1 times negative 2 times negative 1 is positive 2. 1 times 1 times 2 is also positive 2. 4 times 1 times negative 1 is negative 4. Minus 2 times negative 2 times 4 is negative 16. Negative 1 times 1, negative 1 times 1 times 1 is negative 1. Negative 1 times 1 times 1 is again 1. Interesting. You add these together, 2 plus 2 plus negative 4. 2 plus 2 plus negative 4 is 0. You got 0 minus this, and this. Negative 16, negative 1. Negative 16, negative 1, and negative 1 is negative 18. 0 minus a negative 18 is positive 18. Okay, this is interesting. Based on what we're saying, this should go pretty smoothly. And it does. And it does. Again, it's harder to explain this running across 30 feet of a room than it's going to be for the student to just sit down and say, okay, I got a general idea where it's going. Let me do this pencil and paper really quickly if I have to do it, if all else fails. If I draw, if I don't have something else to aid me in this, can I do this old school? It's not particularly hard, but it is on the tedious side. The big thing here is we kind of luck out, it looks like, as far as like some well-behaved answers arising here when we're looking at it. So let's take a look at it. dx is 12, d is 6. Right, I mean, dx is 12, d is 6. dy is negative 6, d is 6. dz is 18, and d is 6. That's kind of neat. At the end of the day, we've got x, y, z, 12 divided by 6, negative 6 divided by 6, 18 divided by 6. Pretty well behaved if they're right. Two, negative 1, 3. And there it is. Again, this stuff goes a lot faster if you're not trying to walk people through it, but obviously the job of the teacher is to walk you through it. So I did walk you through it. Afterwards, you're just going to play the game, or at least if you're comfortable with it, you're going to do it pencil and paper. You're not going to run all over the place, and it goes relatively quickly for 3 equations and 3 unknowns. There's many people who prefer to do the determinant method to solve these equations. Many people who prefer to use the determinant method to solve these equations as opposed to doing the elimination method. Sometimes it goes faster when it's 2 by 2 or when it's 3 by 3 even, if you get into a pretty good pace to do it. It goes pretty quickly. Just be careful. I mean, it's obviously in mathematics it's easy to make mistakes as well. So what do we got here for an answer? For number 12, we have 2 comma negative 1 comma 3. 2 comma negative 1 comma 3. There it is. All right. That was 12. 13 and 14 are going to proceed in a very similar manner. Let's take a little bit of break on that, and let me come right back to it, and let's look at 13 and 14 on there. Should go pretty smoothly. We know the rules now. Again, if you don't have the calculator with you, if something happens, whatever, the calculator's, a lot of things can happen. It's good to know how you do some of this stuff old school, okay, when you're doing it, okay? All right, let's hold on for a second. Okay, guys, let's look at 13 and 14 and do the same thing with matrices and determinants. The way it's written for 13 is this. As we said, if there's nothing in front of the letter, there is a 1 in front of the letter. If there is subtraction, please make it into addition. And then play the game from there. You're going to be finding at the end of all this, you're going to find what d equals. You're going to find a d sub x, a d sub y, a d sub z, and we can take it from there. The d is going to be 621 6, 2, 1, -1, -3, 1. Forgive me. Yeah, right. 6, 2, 1, 6, 2, 1, -1, -3, 1. 4, -1, 1. And, the usual. Pick up these columns, move them over here, while still leaving them over there. And we'll follow the same procedure as last time. You're going here, you're going here, you're going here, and you're adding all those together. 6 times -3 times 1 is -18. -1 times -1 times 1 is 1. 4 times 2 times 1 is 8. 1 times -3 times 4 is -12. 1 times -1 times 6 is -6. And 1 times 2 times -1 is -2. All right, let's see what we got here. That's 9. 9 and -18 is -9. This and this and this. They're all negatives, as we said. -8, -20. -9 minus the -20 is -9 plus 20 is 11. So D's 11, and we take it from there. We have from here, let's go d sub x, d sub y, d sub z, just down the line here, I guess you could say. D sub x, substitute, and make the moves you got to make. Take for the x's, the x column, the 2, the 6, the 2, the 1, get rid of it and go 2, 3, -5. 2, 3, -5. And then you got -1, -3, 1. 4, -1, 1. 2, 3, -5, -1, -3, 1. And here we go. Go here, go here, go here. Let's see what happens. Do this multiplication, you got -6. Do this multiplication, you've got -5. Do this multiplication, you've got 12. Go here, go here, go here. -5 times -3 is positive 15 times 4 is 60. 1 times -1 times 2 is -2. And 1, 3, and -1 is -3. Sounds good to me. I'll add these together. -6 and -5 is -11. -11 and 12 is 1. Minus whatever's going to happen here. This and this is -5. With this is going to be 55. Minus 55 plus a -55 is -54. Again, these numbers aren't necessarily going to be pretty. Heck, they're not necessarily going to be right. Let's just see if they actually even come out. They want decimals when they're doing these at the end, so they want it rounded to 2. Let's see where we are here. It's 2 places. So 13 and 14 are going to be less than pretty. Let's just see if they actually even work. But that's d sub x. Here we go again. 6, 2, 1. In place of the y column that you had, you're going to put 2, 3, negative 5. 2, 3, negative 5 in place of that. 4, negative 1, 1. And let's go. Let's take these first two columns, while leaving them where they are, also put them here. Six times 3 times 1 is 18. 2 times negative 1 times 1 is negative 2. 4 times 2 times negative 5 is negative 40. 1 times 3 times 4 is 12. Negative 5 times negative 1 times 6 is 30. And 1 times 2 times 2 is 4. When you add these together, you got 18, you got negative 2. 18 and negative 2, 18 and negative 2 is 16. 16 and negative 40 is negative 24 minus whatever's going to happen here. Add these together. This is 16 and this is 46. Minus 46 is plus a negative 46. That's a negative 70. Again, you got to be careful not to make any kind of careless mistake. These aren't going to look as easy as the other one did, as far as they're not going to be as they're not going to be numbers like 2, 3, 4. There's going to be decimals all over the place. Well, that happens. That's the mathematics. Let's go. D sub z let's go 6, 2, 1. Let's go negative 1, negative 3, 1. Put 2, 3, negative 5, 2, 3, negative 5 in place of this column. Okay, you're just replacing the columns like you've done in the past. 6, 2, 1 right here again. Negative 1, negative 3, 1 right here. Here goes. 6 times negative 3 times negative 5. At the end of the day, negative 3 times negative 5 is positive 15 times 6 is 90. Negative 1 times 3 times 1 is negative 3. 2 times 2 times 1 is 4. 1 times negative 3 times 2 is negative 6. 1 times 3 times 6 is 18. Negative 5 times 2 times negative 1 is going to be 10. Yeah, I mean, there's a lot here, guys, obviously. This is 91. This is whatever it's going to be. This is going to be 12 with this is 22. $69. So what do we got? Well, let's see what we got, actually. Is a good question to ask. Having done all that, see if all these are going to come out here. Now, again, the exact answers, assuming we've done all the busy work right, the exact answers in terms of fractions are probably the easiest way to go. D sub x over d, d sub y over d, d sub z over d. That's negative 54 over 11, exact answer. Negative 70 over 11 and 69 over 11. in terms of, that's it, period. I mean, and that's going to get you, that's x, that's y, that's z. Again, assuming the arithmetic was right. I hope it is. A lot of work goes into it. Obviously, it's a little easier pencil and paper rather than running all over the place, but I'm saying this. What is that? I mean, in terms of rounding it to the nearest hundredth, you can round these to the nearest hundredth, and we know how to do that. Negative 4.91, a round off there. .36, that's a negative. Well, let's see if those are the answers that they got there for their round-offs. Yeah, they are. It comes out just fine. Again, it's, it can get a little tedious. Some people prefer doing it like this, though, believe it or not. If they got the actual technique down for two equations and two unknowns, and for 3 equations and 3 unknowns, this goes relatively fast, albeit tedious, but this is what we got here. You go x, comma, y, comma, z. X will be negative 4.91, y will be negative 6.36, z will be 6.27 for this one. So, right, let me just kind of look at it. Negative 4.9, negative 4.91, negative 6.36, and 6.27. Absolutely, spot on. It's working. And we proceed. Well, we follow the same procedure here with 14. Now, at 14, they had the x's the way they originally got it written. They got the x written over there. I'm going to line everybody up. Well, there's no x right here, so you're going to go 0 times x to make that happen. The x right here is 1x. Minus 2y is plus a negative 2y. There's no z, so I'm going to call it 0 times z. The z is 1z. Minus 4z is plus a negative 4z. You always move everything around. Do all the mathematical manipulations needed to have all the x's in the first column lined up with each other, all the y's in the second column lined up with each other, and all the z's in the same column lined up with each other. First column is all x's and the coefficients associated with the x's. Second column is all y's with the coefficients associated with the y's. And third column is all z's with the coefficients associated with the z's. As we said, all x's in the first column and their coefficients associated with them, so on and so forth. You've got to make them line up. All x's, all y's, all z's, everybody's got to be plus. If nobody's present, put a 0 and an x. There was never an x here. Okay, 0 times x works. There was never a z here. 0 times z works. It's not there, but put a place value there. Put some kind of placeholder there and get this thing to work. All right, guys, so that's what they're doing right there. Let's see how this all works out. It's going to be the same game, you guys. Same game we've been playing, right? So let's just find out who's who and kind of go for it. Tell you what, let me just erase a whole bunch of stuff here, guys. Give myself a little bit more room. Okay. I'll leave that there. Not a big deal. One way or the other, we're just going to get it. Let's try to find everything we need to find. For number 14, the D, just go down the line now. First column, 103, -2, -7, 5. 103, -2, -7. 103, -2, -7, 5, 0, 1, -4. Those zeros in there are kind of going to make things a little easier sometimes. You'll see. Take these two first columns, leave them alone where they are, but also take a copy of them and bring it here to do some of the trick that we're doing with this. And let's go. Let's go here, here, and here. 1 times -7 times -4 is 28. -2 times 1 times 3 is -6. 0 times 0 times 5 is really 0. -3 times 3 times -7 times 0 is 0. 5 times 1 times 1 is 5. And -4 times 0 times -2 is 0. If I add these together here, I got 22. If I add these, I got 5. 22 minus 5 is 17. Again, kind of a tough number to deal with. Frequently you're not going to get maybe the nice easy numbers, 0, 1, 2, 3, -5, -6. It's going to be maybe decimals all over the place. That's not guaranteed. There might be regular, might be natural numbers that are pretty easy to deal with, and that won't be a problem. So that's what D is. So what we have here is, we've got right here. According to this, D is 17. Let's get dx. Let's get dy. Let's get dz. Because there in the end, we're going to figure out what's going on. All right. As we say, let's figure out what dx is. Let's figure out what d sub x is. So for d sub x, you're going to replace the first column with the column of constants at the end over here, the -2, 0, 9. So we got -2, 0, 9. Everybody else is okay then. -2, -7, 5. See what else we got here. Right. We got 0, 1, -4. Take the first two columns. -2 times -7 is positive 14. Positive 14 times -4 is -56. -2 times -7 is positive 14. Positive 14 times -4 is -56. -2 times positive 1 times positive 9 is -18. 0 times 0 times 5 is 0. Come on over this way. 9 times -7 times 0 is 0. 5 times 1 times -2 is -10. And -4 times 0 times -2 is 0. Okay, kind of interesting. This would be dx. We got over here in the first quantity that's being added together, -56 and -18 and 0. -56 and -18 is -74. Minus a -10 Minus a minus is plus. Got negative 64 right there. Yeah, 68 would be easier, wouldn't it? 17 goes into 68 4 times. Well, that's not what it is. Assuming we're doing it right. Now, we did the first one right, number 13, went straight on just fine. Let's go to dy, then let's go to dz, and let's figure out what's going on here. Okay, so dy. Well, in place where the y column is, the negative 2, negative 7, 5, get rid of it and put negative 2, 0, 9. So negative 2, 0, 9 in the middle. And go 1, 0, 3. 0, 1, negative 4. Let's take these two columns, bring them over, the first two columns, bring them over. Let's go for it. We got 1 times 0 times negative 4 is 0. We got negative 2 times 1 times 3 is negative 6. We got 0 times 0 times 9 is 0. We got 3 times 0 times 0 is 0. We got 9 times 1 times 1 is 9. We got negative 4 times 0 times negative 2 is 0. This is negative 6. That's all negative 6. This here is 9. Negative 6 minus 9 is negative 6 plus a negative 9, which is negative 15. So that was dy, negative 15. Yeah, this is pretty interesting stuff here, guys, how it plays out. It looks like it's pretty consistent, but let's see what's going on. Let's put the dz in there and figure out where we are. Again, this is a lot easier. This little trick can be done by hand, pencil and paper, just sitting down at a desk going pencil and paper. It goes relatively quickly. I mean, it's harder if you're running all over a blackboard, obviously. But pencil and paper goes okay. Also, graphing calculators can do it. Computer programs can do it. dz. Take the z column, the 0, 1, negative 4, the 0, 1, negative 4, get rid of the 0, 1, negative 4, and put negative 2, 0, 9. Then you got 1, 0, 3. Then you got negative 2, negative 7, 5. One, 0, 3, negative 2, negative 7, 5. You go here, you go here, you go here. 1 times negative 7 times 9 is negative 63. Negative 2 times 0 times 3 is 0. Negative 2 times 0 times 5 is 0. Three times negative 7 times negative 2 is positive 42. 3 times negative 7 times negative 2 is positive 42. 5 times 0 times 1 is 0. And 9 times 0 times negative 2 is also 0. You got negative 63. You've got, right, you got negative 63, you got the other guy's 42. Minus 42 is plus a negative 42. That's negative 105. So when the numbers are on, right, it looks pretty good. Let's figure it out. I mean, it's fine. Let me. Let's just take what we got, guys, and take it from there. I think we're okay. I think we're looking all right. Let me just make sure. Right, they're all going to be negative numbers. They're not going to be that easy to look at, but they're not bad. If they're the answers, they're the answers. It's as simple as that. So x. And they got to round it, like I said, if they need to do it. Round to hundredths when necessary. Let's see what we got. We got negative 64 over 17. That's the exact answer, actually, for x. It's, what is it? It's, well, you know what it is. I mean, it's basically dx divided by d is the x, y divided by d is the y, and dz divided by d is the z. So negative 64 it is. There are your answers. Let's get an approximate answer. I'll say equal, but they're not equal technically because these repeat. The full expansion, we want to look at some kind of repeating notation, but it will say it's roughly equal. The exact answers are these. Now let's just take and evaluate these fractions in decimal form and round to the nearest hundredth. So, see where it goes, I guess. Negative 64 over 17. Negative 3.7647. Negative 3.76. Not exactly equal to it. We have to have it go repeating. But for our purposes, is what it is. We got negative 15 divided by 17. 0.88. Negative 0.88. Negative 105. That's 6.176. 176. The 6 rounds it up to a 8. And here it is. Yeah, I mean, let's just confirm it real quick, I guess you could say. Rounded to the nearest hundred, they got negative for number 14. X is negative 3.76. Y is negative 0.88. Y is negative 0.88. Z is negative 6.18. Yeah, spot on. It's there, guys. For our purposes, rounded to the nearest hundredth, we've got this. X comma Y comma Z. And we see what we got. I mean, we got negative 3.76, negative 0.88, negative 6.18. Absolutely. It's, you know, like I said, once you get the hang of it, it can go pretty fast. Old school as well. When you're dealing with two-dimensional space and three-dimensional space, when you're dealing with two equations and two unknowns, and three equations and three unknowns. Two equations and two unknowns and three equations and three unknowns works pretty good. All right, guys. Let's kind of drive toward the finish line here. We've got 15 through 24 to try to do. So let's get a setup on that. Let's try to do it. Got a little bit of room to do 15, so I should be able to do that here, and we can take it from there. And like I said, all of that just went over here. For that to happen. Let's look at 15. I'm a little bit running out of chalk, guys. We'll figure it out. For 15, they got some really excellent problems the last 10 problems or so. Pretty excellent, pretty good. Should go pretty straightforward. Not quite as tedious as some of the other problems were. Very important though as well. For number 15, the sum of two numbers is 46. Twice their difference is 24. What are the two numbers? So they're basically saying let's say there's two numbers here, guys. Here are the two numbers, x comma y. Let's find out what they are. They're saying the sum of two numbers is 46. Take those two numbers, add them together, and that's the sum of the two numbers. Twice their difference is 24. What are the two numbers? Well, we're going to have to say that we got to choose one of them arbitrarily to be bigger than the other. Because if there's a difference and there's a positive difference, one's got to be bigger than the other. If the difference between the two is 0, that means they're the same number. So just 2 times x would give you 46. X, or 2 times y would give you 46. X and y would each be 23. So we're going to have to assume that one of them is bigger than the other. Let's arbitrarily, it doesn't matter which one you choose. Arbitrarily, let's choose that x is greater than y. They're saying that the sum of two numbers is 46. The sum of two numbers is 46. Twice their difference is 24. What are the two numbers? Twice their difference is 24. That's it. I mean, this is what you have to have in mind, and you're basically solving two equations and two unknowns to make this thing happen. 2 times x is 2x. 2 times y is 2y. 24 is 24. X is x. Y is y. 46 is 46. Tell you what I'm going to do. I'm going to multiply the top by 2 and end up getting 2x plus 2y equals 92. Then I'm going to add it to the second one to get rid of the y's. You can see that the y is there. I engineered it to be able to add these two and get 2y and negative 2y to cancel out. I add these, I get 4x equals the addition of this, which is 116. 4x equals 116. Divide by 4 on each side. 4 goes into here 29 times. Okay. What would y have to be? Well, wait a minute. What y is going to be, it's going to be pretty easy. X plus y equals 46. Just go back in here and plug in what you said x was equal to. Plug in what you said x was equal to. In other words, x plus y is 46. Put a 29 right here in for x. I don't know what y. Got a 46 right here. I'm going to subtract 29 on each side. When I do so, I get 17. Jackpot. We got it. Is it true? Is it true that 29, is it true that 29 and 17 is 46? They did tell us that the sum of two numbers is 46. Yeah. The difference between the two, we assumed x was bigger. 29 minus 17 is 12. Twice the difference is 24. 29 minus 17 is 12. If you double 12, you get 24. 29 minus 17 is 12. Double 12, you get 24. 29 plus 17 is 46. Everything checks out, guys. Everything checks out. That's number 15. Let's go 16 all the way through 24. Let me clear this out a little bit. We'll take it from there. Let me just pause this. Okay, everyone. Let's keep going. Let's keep looking at some of this content. Try to straighten out my chalk situation here a little bit. So let's see what we can do and what we can say. And we'll take it from there. As we said, we have finished all the way through problem number 15. All the way through problem number 15 we have finished. Let's talk about problem 16 and keep going at a decent pace, I hope. It says here for the word problem, and you'll have it scrolling at the end of the video anyway, and you have it in your possession if you're in the particular class that has the tech math. If you're not in that particular class and somewhere else, in a physics class or something, you'll have this practice content scrolling at the end where they have the actual questions. Now, we've talked about that already. For number 16, there were 25 more children's tickets than adult tickets sold to a spaghetti dinner. Adult tickets cost $4 and a child's ticket cost $2.50. Total sales were $498. How many of each type of ticket were sold? I'll say these are children's tickets. We'll call it X. There were 25 more children's tickets than adult tickets sold. Children's tickets, so we'll say X number of children, Y number of adults. Sounds good. There were 25 more children's tickets sold than adults tickets. So if adult tickets are Y number of them, add 25 to the adult number tickets, add 25 to that, and you got the children's tickets in there. Adult tickets cost $4 and a child's ticket cost $2.50. So $2.50 per ticket per child, $2.50 per ticket per child, and there's X number of children. $4 per ticket per adult, and there's Y number of adults. Altogether, they made $498. How many of each type of ticket were sold? In other words, there were X number of children. Each child paid $2.50. There were Y number of adults. Each adult paid $4. The sum of all that money comes out to $498. You've got one equation here. You've got another equation here. You've got two equations and two unknowns, and there's a number of ways to do it. I'll tell you what. If the children's tickets are, there's 25 more of the children tickets than there are of adult tickets, wherever you see an X here on the bottom, why don't you substitute this? Y plus 25. So you got 2.5, Y plus 25 here, plus 4Y equals 498. See how that works out. Let's do the distributive principle. This will be 62.5. 4Y here, 498. Okay? Take the 2.5Y and the 4Y. Get them together. 2.5Y and 4Y is 6.5Y. Subtract 62.50. Forgive me. Yeah, subtract 62.5 or 62.50 on each side. Subtract it. If you subtract 62.5 on each side, you should get 435.5. If you subtract 62.5, subtract 62.5, you get, I'm thinking 435.5. Divide by 6.5 on each side. You'll get Y. Let's see what happens here. 435.5 divided by 6.5. 435.5 divided, forgive me, wrong here. 435.5 divided by 6.5. 67. 67 adults. The children are more numerous by 25 more people. 25 on to 67. It's going to be 25 more people than 60. It's going to be 25. It's going to be 25 more people than 67. So that's going to be 90. Quite a few, actually. It's going to be 92. 92 children, 67 adults. So let's see what we got here. Let's make sure, guys. I want to make sure we're not going in the wrong direction here. Right. 67 adult tickets and 92 children's tickets were sold. Sounds good to me. 17. Mr. Keeley drove part of a trip at 85 kilometers per hour and part in a rainstorm at 75 kilometers per hour. He had to slow down. If the 335 kilometer trip took 4 hours, how long did it take the rain shower? How long did the rain shower last? Well, basically for that, you guys, look, I mean, the person, if the total trip took 4 hours, he went T amount without a rainstorm. He went 85 kilometers per hour for t hours. And then he went at 75 kilometers per hour, he went for 4 minus t. And he covered a total distance of 385. 335 rather. So basically what we're talking about is, if it's a total trip of 4 hours, if t of those hours were without a rainstorm, then 4 minus t had to be with the rainstorm, because when you add them together, it is the 4-hour trip. I don't know how long t is. It could be 5 hours. It couldn't be 5 hours, but it could be 3.5 hours. Well, what's 4 minus 3.5? It's a half hour in a rainstorm and 3.5 hours without a rainstorm. T could be maybe 3 hours were in the rainstorm. What do you mean? Well, 1 hour was just without a rainstorm, and then 4 minus 1 is 3. 1 and 3 is 4. So basically that's kind of the logic. There's a number of ways to look at this, but this is pretty straightforward. So what you have here is, and again, I just want to come back to this, guys. That's looking good too. So just look at the way this stuff plays out. When you're looking at this, you're saying 85 kilometers per hour for t number of hours, and the remaining portion of the 4 hours, 4 minus t, you're in a rainstorm. Altogether, you are covering the distance of 335. Well, let's see where this goes. We got 85t. We've got 75. Let's distribute that. Let's just distribute that, guys. We got 75 times 4. We got 75 times t. Minus 75t is plus a negative 75t. Negative 75t and 85t is 10t. Sounds good. Let's subtract 300 on each side. Let's divide by 10 on each side. If it's a 4-hour trip, 3.5 hours were without a rainstorm. But 4 minus t, 4 minus 3.5, the remaining portion, 3.5 hours were without the rainstorm, but 4 minus 3.5 is 0.5, is a half hour. .5 hours. So how long did the storm last, guys? Well, as far as where I was located, where the person was located when he was making this journey, went for a half hour. .5 hours or a half hour? 0.5 hours or a half hour. That's number 17. Let's go 18, 19, 20, and 21. They've got some interesting problems that force you to kind of look at things in a very interesting manner, I think. So let's look at them. So they're saying a bunch of things, guys. Let's us say a bunch of things, I guess. For 18, eliminate A and solve for K. So they're saying A equals KS and K equals W over A. And they want you to eliminate K and solve for A. Don't have K in there. If you're going to solve for A, don't have K in there. There are a number of ways to go here. Take what K equals, you're trying to eliminate K, and wherever you see a K up here, put W over A. So A equals, in place of K, W over A times S. Then you take this, multiply, S is the same as S over 1. W times S is WS. A times 1 is A. Why don't you multiply by A on each side? Why don't you square root each side? Yeah, A equals the square root of the product, WS, for number 18. No idea where they're getting the answer that they have. Usually they're right and I'm wrong. Let's take a look. Eliminate K. Eliminate A. Oh, eliminate A and solve for K. Okay. Mathematically, what I did here is correct. It's just not what I'm being asked to do. They weren't asking me. Here I eliminated K. I eliminated K and solved for A. That's correct if I'm solving for A while eliminating K. That's not what they asked me to do. So that's on me. Let's try it again. Mathematically, I did not make an erroneous statement. I just did not answer the question, which makes my work wrong. Let's try it again. They are saying eliminate A and solve for K. So wherever you see A, put KS right here. So wherever you see A, put that, KS. We got W over A is KS. There we go. That's it. Then multiply by K on each side. And there's your answer. Sorry about that, guys. Corrected pretty quickly, but you are eliminating A and solving for K. 19. They're saying eliminate big G and solve for R. Eliminate big G and solve for R, huh? Well, I'll tell you what. Number of ways to go here, I guess. Let's look at the second one down here. Let me add big G on each side. Add a big G on each side. And you end up getting we end up getting G plus R equals K. Subtract R on each side. We got G like this. So wherever I see a G, I'm going to put this. So I'm going to take this and I'm going to put K minus R right there. So F equals G K minus R. G is equal to K minus R. This is Q times R. And solve for R. Well, okay, good enough for me. What we got here is, here's K. The minus R go over here with that. Go QR minus R. Pull an R out of here. Pull an R out of here, and you got this. Subtract K on each side. Take the Q, the quantity Q minus 1 times R equals F minus K. You know where we're going to go, guys. You know what we're going to do. Stay strong, keep it in parentheses. F minus K, Q minus 1. You can take the parentheses out or leave them in. That's not a big deal. But that's definitely the answer. The quantity F minus K over the R equals the quantity F minus K over the quantity Q minus 1. And they write it. Yeah, you can write it. Actually, you can write it a couple ways, actually. R equals F minus K over Q minus 1, which is what I got there. You could also write it, if you switch the order of the subtraction, this becomes a negative number. It's opposite the sign of what it was initially. But if you make this one also opposite the sign of what it was initially, this is, this right here is this times negative 1. And that right there is this times negative 1. The negative 1's cancel, and it's the same value. If you're to multiply this top by negative 1, it'll switch over. But you got to do the same to the bottom, it'll switch over. The negative 1's cancel. So you got what you got, and it's also the same answer as this. So either one's fine. They went there. They said it like that. Depends where you're going to find. You can't just switch one of them. If there is a subtraction going on, my friends, if there is a subtraction going on, top and bottom, if you switch the order of the subtraction on top and also switch the order of the subtraction on the bottom, there's two items. If there's two items on top, 2 items on the bottom, and there's a subtraction in both places, if you switch the order of the subtraction on top and you switch the order of the subtraction on the bottom, it's the same ratio. And that's what they're trying to say here. That's 19. Number 20, eliminate S and A and solve for W. So let's take a look at that. S and A and solve for W. So eliminate S and A and solve for W. So what we have here is P equals SW. R equals A plus S. And you want to eliminate S and A, or at least write them in a different form. That's probably a more accurate way to say it. You've got to eliminate S and A. Well, I'll tell you what. If I'm going to eliminate S and A, I'm going to have to find another expression for A and another expression for S, neither one of which has A or an S in them. There's no A and there's no S in them. Tell you what I'm going to do. Take the third equation here, divide by W. A equals T over W. Take this equation, divide by W. Take this equation, divide by W. S equals P over W. Wherever I see an A, I'm going to put T over W. Wherever I see an S, I'm going to put P over W. Sounds good to me. Let's go over here. R equals A plus S. R equals so R is A plus S. We've got to eliminate A plus S. That doesn't mean, well, it means we have to somehow solve. We want to solve for W. We just don't want A and S in the solution. We don't want A and S associated with the solution for W. Well, I'll tell you what. Let's write A in a way that does not have A or S in it. Let's write S in a way that does not have A or S in it. And then let's put it in there. Well, basically, if R equals A plus S, and on this third one here, I solved for A and got T over W. And for S, up here, the first one I solved for S by dividing by W, and I got P over W. A is T over W, based on what happened over here. And so A is T over W, based on what happened here. And S is P over W, based on what happened up there. And I'm here. Wait a minute. We got a common denominator. Now, add the tops, leave that alone. That's it. I mean, that's about what you need to get you through this. You get to here, you multiply by W on each side. WR equals T plus P. They wanted you to solve, as we said, right? And solve for W. And there we are, guys. The quantity T plus P over R equals W. W equals the quantity T plus P. W equals the quantity T plus P over W. Yeah, W equals P plus T over R, rather. I'm sorry, I can't. That's the right answer. Kind of ignore how I said it. Here it is, yeah. W equals T plus P. W equals T plus P over R. Or P plus T over R. Either way, that's fine. That is 20. '21. Eliminate W and R and solve for A. They're doing kind of the same stuff to us. All right, so let's see what we just, guys, let me just number these, right? So this was pertaining to number 20. And here's your answer. As we said, W equals T plus P over R, or W equals P plus T over R. The order of the addition obviously does not matter. For 21, eliminate W and R and solve for A. Eliminate W and R and solve for A. Let me multiply by, for the top one, let me multiply by D on each side. And W is equal to D times T. On the bottom one, let me divide by A on each side. Let me divide by A, for the bottom one, let me divide by A on each side, and R is equal to D over A. They want you to eliminate W and R, so wherever I see a W, I'm going to put DT. Wherever I see a W, I'm going to put DT. Wherever I see an R, I'm going to put DA. That'll do it. Wherever you see the W, just put DT instead. Wherever you see an R, just put D over A instead. And that's going to do it for you. Let's kind of use this as the launching pad for the whole thing. They want you to eliminate R, huh? We said R was equal to D over, let's take this right here. Let's just work with that. It's D over A is R. The W is T times D, or D times T. The W is, the W is D times T. The R is D over A. And they want you to solve for A. A lot of ways to go here. Tell you what, put these in parentheses. Don't have to, but you can. Multiply by A on each side. Divide by the quantity D times T plus P on each side. When you do that, they're gone. You got A left over here, which is what you wanted. A equals D over the quantity dt plus P. That was 21. Solve for A. Okay, we should have that right now. Yeah. Here it is. Yeah, they write it a little different order than I write it, but that's not a big deal. Basically what they're doing is they're saying A equals D over the quantity, D times T plus P, or A equals D over the quantity P plus D times T. D over the quantity P plus dt is also equal to A. Either way, that's fine, the way they got that written. So we got 22, 23, 24 to write, and we're doing pretty good if we do that. See what we can say. That's okay, guys. Let's go. 20, 23, 22 rather, 23, 24. Okay. Let's finish this thing out, guys. 22. 22, an airplane flew 600 miles in 3 hours with the wind. Flying back against the wind, it flew 450 miles in 3 hours. So, again, let's talk about it, guys. An airplane flew 600 miles in 3 hours with the wind. Flying back against the wind, it flew 450 miles in the same 3-hour time span, or in a 3-hour time span. Find the speed of the plane in still air and find the wind speed. Okay, I don't like the way I read this, but hopefully this makes some sense, you guys. Basically, in a 3-hour period of time, the airplane can fly 600 miles if the wind is helping it. In another circumstance, with an equal amount of time that was transpired earlier, 3 hours, if it's going against the wind, it can't go 600 miles like it was able to do earlier with the wind. 600 miles with the wind in 3 hours. But against the wind, a 3-hour time span afforded it won't get it to 600 miles because it's fighting the wind. It can only go 450 miles. So from there, we can find out the speed of the airplane when there's no wind, and we can find out the wind that's going on there. The way you want to look at it is this. The airplane's got speed r in still air. It's got the airplane has speed r. The airplane has speed r in still air. Add the wind speed, and then if you let it go for a time t, it'll cover. Okay, let's back up a little bit. There's a number of ways to write this. I'm already complicating this, so I'll try not to do that. The speed of the airplane in still air is just r. If you add the wind speed to it, r plus w is the speed that it has in total if it's going with the air, with the wind. So still air speed of the airplane without any wind whatsoever is r, but if you add the wind speed and the wind speed is helping the journey, then r plus w is the speed of the airplane with the help of the wind. If it goes for 3 hours, it'll cover 600 miles. In still air, once again, the airplane is capable of a speed r, but if it's fighting the wind is going to take away its speed, and that's its speed fighting the wind. Going for 3 hours, it'll only go 450 miles. That is the hardest part of this entire problem. The hardest part of this, if you get it to here, you're doing okay. Let's see what we can say about this. So if we're talking about something like this, you guys. So basically, we could do a number of things here. We got to be careful, whatever it is that we do. That's for sure. Take the 3 and go here. There's a number of things on my mind right here, guys, but we're not going to worry about different ways to do this. Let's just be careful how we're doing this. 3, the top one, distribute the 3 all the way across, and you've got 3r, right? A number of ways to go. This is not the only way you could have done it, I guess what I'm trying to say. Distribute the 3 all the way across, and you get this. Distribute the 3 all the way across, and you get this. Sounds good to me. Tell you what. Take this, and add the 2. You know what's about to happen. The 3w and the minus 3w are out of there. The 3r and the 3r is 6r. This and this is 1,050. Not a bad move, guys. We go right here. R is equal to, trying to actually think of it, it's almost, my guess is, let's see here. I think it's I'm getting 175 here is what I'm thinking, just looking at the old. See if that's actually true. 6, 6r equals 1050. 6 times 175. Let's see here. That would be 450. Yeah, sure comes out okay. That's R. R is 175. If that's the case, there's a lot of ways we can play this, guys. Let's figure out what the heck's going on here. You can use this one or you can use that one. Tell you what, let me use the top one. 3r plus 3w equals 600. Well, everybody just told me that it's 175 for the r. I don't know what w is, but the rest is algebra. Let's figure it out. 3 times this, right, is going to be 525. Let's make sure that's right. Yeah, sure looks like it. Subtract 525 on each side. Subtract 525 on each side, you get this. Divide by 3 on each side. There it is. Looking pretty good. The speed of the wind in this particular problem is 25 kilometers per hour. The speed of the airplane in still air for this particular problem is 175 kilometers per hour. So there's R, there's W. 175 and 25 respectively. Wind, airplane in still air, 175, and wind, 25. Right. Where they could have sworn the problem. Okay, I put it in kilometers per hour, guys. No, it's not. It's miles per hour. That's not something we got to watch out for. It's miles per hour. That's miles per hour. Okay, very good. It's a good amount of stuff here, guys. There's definitely, you're not going to get cheated with the content if you look at this content. Let's look at 23 and 24. Let me put this down here and let's take it from there. Okay. Number 23. How much of 10% alcohol solution and how much of a 10% alcohol solution and a 50% alcohol solution should be mixed to make 200 milliliters of a 40% alcohol solution? It's a great problem. We've seen elements of this even in the discussions on these reviews. We've seen something similar to this already. Basically, let's say X equals amount of 10% solution. Let's say Y equals amount of 50% solution. Basically, if you add the two solutions together, the 10% solution and the 50% solution, they give you 200 milliliters total. I'm not going to put the units on there. It could be 200 gallons, it could be 200 liters, it could be 200 swimming pools. It doesn't matter. As long as the units all agree with each other, whatever they may happen to be, that's okay. In the end, they are going to be milliliters. But that's okay. It's all a proportional phenomenon. As long as all units agree with one another, you're fine. You will take X amount of 10% solution and Y amount of 50% solution. In total, the new solution will be 200 milliliters big, 200 milliliters of volume. You want a 40% solution at the end of it. What does that mean? That means if you took 10% is 0.1. 0.1 times X amount of solution will tell you if 10% of it is pure alcohol, 0.1 times X amount of 10% solution gives you the amount of pure alcohol. This is alcohol. X right here is alcohol and water. 10% of it is pure alcohol. So 0.1 times X is how much pure alcohol you have. This one is alcohol and water or whatever else the solvent is for either one of these. But if you multiply by 0.5, half of it is pure alcohol. At the end, you want of the 200 of this, you want 40% of it to be pure alcohol, and you're doing this. 10% is 0.1, 50% is 0.5, 40% is 0.4. The most difficult aspect of this, you guys, is get it to here. Once you got it to here, just work pretty hard, and you got two equations and two unknowns, and you're going to solve it, and you're going to be fine. What do we got? Well, you're looking at it. You get to there, X plus Y is equal to 200. 0.1x is whatever it is. 0.5x is whatever it is. And 0.4 times 200 is 80. That's a y right here, I'm sorry. And that's 80. A lot of ways to go here, guys. I'd probably take this guy, and I'd probably multiply by 10 just to kind of make it, to get rid of all the decimals. I'll probably multiply by 10 on each side. Take the 10 times 0.1, the 10 times 0.5, you got 1x plus 5y equals 800. This chalk is doing a number on me today, guys. All right, so we got this. The x right here, the y right here, and the 200 right here. This is 1x, this is 1y. And the rest is not too bad. The rest is not bad at all. Take this guy and multiply by -1 all the way across. On the top here now. Multiply by -1 on both sides, and you get this. Then add it to this. I'm trying to eliminate a variable, guys. You make the choice, just get it done. -1x and 1x is 0. -1y and positive 5y is 4y. -200 and positive 800 is 600. 4y equals 600. Divide by 4 on each side. Y is 150 milliliters. What does x have to be? Well, x and y, when you add them together, x plus y gives you 200. If y is 150, do the algebra, you get this. X is 50 milliliters of the 10%. What do we say it was? Let's be honorable with this. Don't mess up what the percent solution is that we're talking about. X is associated with a 10% solution. 50 milliliters of alcohol solution. This is 150 milliliters of 50% alcohol solution. Absolutely. You need more of the 50% solution than you do of the 10% solution. Why? You're bumping it up not to 15 or 20, you're bumping it up to 40. You're not bumping it up to like 12%, you're not taking it from 10% and 50%, you're not taking it from 10% up to 12% or 15% or something. You're taking it up to 40%. So it makes sense you probably need a lot of the more densely concentrated alcohol solution. And you got this. And the way they look at it, I always want to check, guys. Okay. They got 50 milliliters of 10%. Yeah, 50. Correct. 50 milliliters of 10% solution and 150 milliliters of 50% solution. Sounds good to me. All right, looking good. Let's do the last one, guys. Let's do 24. Okay. 24, they want you to find force F1 and force F2. They're using terminology that's not really technically used in physics, but in terms of proportionalities involved, I guess we can allow it. Forces are in newtons, and that's kilograms meters per second squared. They're just using kilograms. Arguably, you can use many different kinds of units to talk about things. In the technical sense, when they're talking about physics, they are going with newtons, and that's kilograms times meters per second squared. They're just going to use kilograms. We'll work with them on that. There is a mathematical validity associated with that, even though it's not commonly discussed, especially in physics, in a formal physics class. For number 24, to find the forces F1 and F2 in kilograms in two beam supports, the system below was set up. Solve the system, and basically you're done at that point, guys. So to find the forces F1 and F2 in kilograms in two beam supports, the system below was set up. Solve the system. It's kind of like when I made the mistake earlier, I called it kilometers per hour. Well, the numbers were all fine. If they would have been talking about kilometers from the get-go, yeah, that's absolutely the right answer. If they're talking about something else and all those numbers were as they were, the numerical answers would be right. We just got to watch out for the units. Same thing with this here. They want to talk about kilograms, then we'll call them kilograms. We got F1 plus F2, and if you add them together, you got the 600 kilograms that they're talking about. Here they're saying if you take 2F2 plus 200, you get 2F1 plus 400. Well, guys, there's a bunch of ways we can play this thing. Let's go for it. Take this second guy and subtract 200 on each side. You end up getting 2F2 equals 2F1 plus 200. Then you can subtract 2F1 on each side. Two F1 on each side. Well, that's there. The 200 is here. This is 2F2 minus 2F1. Look at it carefully. You can take this right here and factor a 2 out of here. On the left-hand side, you can factor a 2 out. On the right-hand side, you can factor a 2 out. And you end up getting yeah, I factored a 2 out on each side. You know where I'm going. Divide by 2 on each side, and I've got F2 minus F1, that goes, equals 100. True. This one is F1 plus F2 equals 600. F1 plus F2, just add them up in different orders, guys. It doesn't matter the order I add two things. F1 plus F2 equals 600. That's the same as F2 plus F1. You know where I'm going. Really, one of the more important moves you're going to make in this problem is right there. That's it. You solve that, you're pretty much there, and it's not a hard one to solve at that point if you can get to there. Let's go for it. Let's take two equations. F2 and F2 is 2F2. F1 and negative F1 is 0. 600 and 100 is 700. You can divide by 2 on each side. F2 is equal to 350. They're using kilograms. I'm going to use kilograms. Good enough for me. F1, we know that if you take F1 and F2 and add them together, you get 600. Right here. F1 plus F2 gives you 600. If F2 is 350, 350 plus 250 gives me 600. Just subtract 350 on each side. Everybody sees that now, right? I mean, it's basically F2 plus F1 equals 600. F2 is 350. 350 plus something will give you 600. 350 plus 250, do the algebra and we're there. F1 is 250 kilograms, F2 is 350 kilograms. Right. F1 250 kilograms, F2 350 kilograms. Looking good, guys. There's a lot of stuff here, guys. It always takes a while. When you're doing this on your own, it shouldn't be too bad. I mean, when you're doing it pencil and paper, you travel a lot faster than having to kind of run across a room and stuff like that. As the teacher, my job is to run across the room, so that's what I'm going to do, and it's a lot of fun to do it. It's going to be faster generally for anybody, including myself, if you're just sitting down and doing it pencil and paper, okay? But these are the arguments that you're looking at as we show it on the board. I hope this helps you out. That was the 7th practice exam of the old book that they used to have, and it doesn't matter. For our purposes, these practice exams are excellent. They comprise kind of a book for us that we're doing here. There's a lot of stuff here, guys, but look at it because it's almost entirely a textbook that we're going through, or at least a good part of a textbook, a large part of a textbook. So for chapters 13 and 14 review, that's what we just did, problems 1 through 24. All right, we'll see you soon.